So today we're going to take a look at figuring out the volume and the surface area of prisms. So prisms are three-dimensional shapes. You can think about equating the object shapes to real-life objects that you might see in your everyday life. So a rectangular prism you might think of as a regular Lego brick. So that's what you can sort of equate to that. We're going to take a look at a lot of different three-dimensional shapes over the course of this unit, so it's important that you can sort of visualize what they are. So now that you have visualized what this might look like, then we are going to calculate or identify the length, the width, and the height of this particular object. And we do that so that when we substitute into the formulas for surface area and volume, we've identified the correct measurement for the correct value. So we're going to use our width as 5 centimeters, our length as 12 centimeters, and our height as 3 centimeters. If you end up switching these around, that's okay, because the volume for a rectangular prism doesn't necessarily is not necessarily affected by the order that you place them in. So the volume of a rectangular prism tends to be a little bit easier to calculate than the surface area because there's less steps. So let's start with that one. So the volume is length times width times height. So we're going to do 12 times 5 times 3. And you can multiply these all three in one step. So 12 times 5 times 3 gives us 180. And we have to make sure that we always include our units. So our units are centimeters, and because we've calculated the volume, we have cubed units, or centimeters cubed. The next thing we want to look at is the surface area. And you'll notice that there are two versions of the surface area formula that you could choose from, and it doesn't matter which one you choose. You're both going to end up with the same final response or final answer. So I'm going to use the first version of this formula. So 2 times length times W plus length times height plus width times height. So now I'm going to substitute in the numbers for my variables. So length is 12 times 5 plus 12 times 3 plus 5 times 3. We have to make sure that we follow order of operations. That's going to be very key. So we have to do our multiplications first before we can do any additions. 12 times 5 is 60. 12 times 3 is 36, and 5 times 3 is 15. So the next thing you want to do is do what's inside of our bracket. So we're going to do our addition. So 60 plus 36 plus 15 gives us 111. And if we multiply that by 2, we get 222. And our units are centimeters, and because it's a surface area, so just like our regular area, we're going to have squared units, or centimeters squared. Moving on to the triangular prism, again, this is a total round bar, so that's the easiest sort of shape to picture. We are going to refer to our formula sheet to determine which measurements along our shape are labeled as A, B, C, H, and L. That's going to be very important, especially when we are figuring out which value is which, so that we don't put the wrong measurement in the wrong formula or in the wrong place. So these measurements along the side of your triangle are going to be A. Your B is always going to be the base of your triangle, and then C. So A, B, and C. And then we're going to calculate our length. So the length in this case refers to the height of the triangle. I know that's a little confusing, but that's what we look at. And then the height of the prism refers to as the height of, in this case, is 15. So now that we have those labeled, we want to now, again, calculate the volume and the surface area. So we're going to start with volume again. Volume is base times length times height divided by 2. So the base is 6. Our height, our length, is the height of our triangle, which is 4. And the height of our prism, which is 15. And that's all divided by 2. 6 times 4 times 15 gives us 360. 360 divided by 2 is 180. My units in this question are feet, and again, because it's volume, it's feet cubed. So now we want to do the surface area. So this is where labeling the sides correctly is very important. So that's where it's going to be necessary when we're doing our calculations. So our A in this case is going to be our 5. And we're going to assume that this is an isosceles triangle so that both of our sides, A and C, of our triangle are going to be exactly the same. So our A is 5 times our height, which is 15. Our B is 6 times our height of 15. Our C is also 5 times our height of 15. Our base is 6 times our length, which is, this should be an addition sign right there. And then 6 times our length, which is 4. So the first 3 are the sides of our triangles times the height of our prism, and then the last one is just the height and the base of our triangle. So now we need to calculate these. So we're going to start with our multiplications. So 5 times 15 is 75. 6 times 15 is 90. 5 times 15 is 75 again, and 6 times 4 is 24. So now that we've done all of our multiplications, we can add all these up in one step. So 75 plus 90 plus 75 plus 24 gives us 264. And our units are feet squared. So now that we've done a quick, simple example for each of those, let's see if we can use that information to help us with a word problem. So a rectangular prism has a volume of 18,000 centimeters squared. This should actually be a cube, so you can change that on your sheet to a 3 because volume is units cubed, and a base of 25 centimeters by 60 centimeters. We want to find the height and then the surface area of this rectangular prism. So we're going to start by sketching a rectangular prism. It does not have to be perfect. So I'm going to try that again though. All right, something like that. Okay. So now what we want to do is we want to label what we know. So we know it has a base of 25 by 60. So we can label, let's do this, the shorter side of my base is 25. This is centimeters, and the longer side of 60 centimeters. So we're trying to find the height. So I'm going to label this as my H. And I know that the volume is 18,000 centimeters cubed. And I want to find the height. So in order to do that, what I want to do is I want to think about what the formula is for a rectangular prism. So So the formula for a rectangular prism is length times width times height. So now I'm going to substitute in what I know. So my volume is 18,000. My length I'm going to use as 25. And my width I'm going to use as 60. And then the h is still our unknown. So we want to simplify our calculation on our right-hand side. So we're going to work out 25 times 60 first, which gives us 1,500 times our h. And now we want to solve for h. So we want to move the coefficient in front of the h to the other side. And we do that by dividing both sides by 1,500 so that it eliminates itself from the right-hand side. And we can do the calculation on the left-hand side to solve for our height. So 18,000 divided by 1,500 gives us 12. So that equals h. So the height of my prism is going to be 12 centimeters because those are my units. So once I've identified the height of my prism, now I can calculate my surface area. So before we use the first version of our surface area formula, so why don't we go ahead and use the second version, so the 2LW plus 2LH plus 2WH, for you to see that variation. So surface area, so 2LW plus 2LH plus 2WH. And again, it doesn't matter if they're in a different order from the formula, as long as you have each set of variables. So length times height, and width times height. So I'm going to use 25 for my length again, 60 as my width. My height I calculated out as 12. All right, so now it's a matter of following order of operations. So I have to do my multiplications first. So 2 times 25 times 60 is 3,000. 2 times 25 times 12 is 600. And 2 times 60 times 12 is 1,440. So the last step is to add those all together for a final answer of 5,040. And my units are centimeters squared because it's surface area. So we've reverse engineered this formula for volume to help us find a missing measurement within our prism. And then we've used that information to help us find the surface area. So now you're exposed to the different version of that surface area formula. So like I said before, it doesn't matter which one you use, you will always get the same answer. One last example involving a triangular prism. So again, I'm going to sketch a diagram. And it doesn't have to be perfect, just as long as you have a general idea. So a triangular prism has a length of 10. So you'll notice that if we look at this question, we don't necessarily have, if we use 10 as the length here, then we don't have enough information to find the height of our prism. So in this case, I know we've labeled our length as the height of the triangle, but we're going to use the length as the length of our prism. And you're going to find out why in just a moment. So then it says the base of the triangle is 2 inches. And the side of the triangle, so this measurement right here, is going to be 3 inches. So If we know the sides of our triangle, and we're going to assume that these are isosceles triangles, then we can find the height of our triangle by using Pythagorean theorem. If we use the length as our 10 here, well, obviously it wouldn't work because our hypotenuse can't be smaller than another side of our triangle. So that's why the 10 has to be the height of our prism. So using Pythagorean theorem, we are going to find the height of our triangle. So we are going to assume that it cuts right through the middle. It's not going to let me draw on top of this, unfortunately. But we're going to assume it's going to go right down the middle. It's going to split this triangle directly in half. So that if I was to recreate the shape down here, because we're splitting the triangle in half, then the base of this triangle is only going to be 1 inch. And we're going to solve for this side right here. In this case, if we look at Pythagorean theorem, our 3 is our C because it's directly across from the right angle. Our 1 can be our B, and the height of this triangle can be our A. So sometimes we have to use some other information that we've learned previous in our course to help us solve for missing sides. So our A squared is our unknown. Our B squared is 1 squared, and our C squared is 3 squared. 1 squared is 1 times 1, which is 1. 3 squared is 3 times 3, which is 9. Moving our 1, or eliminating our 1 from this side, we do that by subtracting. So we're subtracting 1 from each side. So we have A squared, these two cancel each other out, is equal to 8. And now we need to go from A squared to A, and we do that by doing the opposite of squaring, or finding the square root of 8. And that's not going to be a nice whole number, so we can use 1 decimal place for this. So when I round it to the nearest tenth, it'll give me 2.8, and my units are inches. So now that we have the height of this triangle, now we can solve for the volume. So the volume of a triangular prism is base times length times height divided by 2. So in this case, our base is the base of the triangle, so 2. Remember from the formula, the length was actually the height of the formula, or of our triangle, so that becomes our 2.8. And the height is the height of the prism. In this case, it's going to be 10, and we're going to divide this by 2. So I have 2 times 2.8 times 10. That's 56. And I'm going to divide that by 2 to give me 28. And my units are inches cubed.